Hi, welcome to Module 6, where we talk about the tools that we need to build GenAI apps. It's very easy to build GenAI apps. At the same time, it's very tough if you don't understand what are the libraries that you need to use within Python on how to build these apps, scale it up, and if you did not understand any of the modules that we have discussed above, it would be a little tough for you to build an GenAI app. Let's understand what's in store. The main fundamental block of building a GenAI app within Python is LangChain. If you go to Google and type LangChain, you're going to get a page of LangChain. And once you open it, if you go to the entire web page of LangChain, you will be understanding how do you start setting it up, how do you start executing, and how do you play around using different offerings. For example, Azure OpenAI offering needs certain libraries from LangChain to import and utilize. Likewise, when there is an offering from OpenAI, how do you import that particular function and connect it to the API key? So these are the nuances that you need to grasp from the LangChain library homepage. Coming to the user interface of your GenAI app backend is very easy if you are looking for a Python related UI app. So you can go ahead with Streamlit, which helps you to rapidly develop an UI chatbot and deploy it. Now, if you remember, I spoke about embeddings and we need an embedding model. So you have many models in the model hub of Hugging Face, which you can utilize, and there are a lot of emerging tools. When we discussed RAG, we spoke about agentic RAG agents and how do you use them. Uh, so to use them, you have AutoGen, an offering from Microsoft Azure, which helps you to quickly build agents. Then you have Langsmith and Gradio that helps you with the interface of it. So you can utilize either of these two to build an interface for the backend that you scale up in Azure AutoGen. Now, why are these tools, called as the game changers? Because they make the GenAI app building fun and easy. Let me start asking you a question. How many of you have tried to build an AI application from scratch? If you remember, if we have to build from scratch, we need to convert whole of our data into mathematical vectors, which is incredibly complex. That's exactly why we need these tools in 2025. So currently what we are seeing is, can we build it was a question of the past. Now the point is, how fast can we deploy applications? That is the main question. Now these tools that have come up in 2025 and before, they have transformed the months of development into hours. So you can build a generative AI app in hours. So here is what that makes it revolutionary. Developer velocity has increased by 10 times. You can literally go from idea to a working prototype in a single day. But more importantly, these aren't just for the prototypes anymore. Using these libraries, you can actually deploy an app and also add observability. Let's talk about observability here. Now, observability is basically a monitoring system to understand how well the LLM is able to interpret your questions and respond to it. Basically, it helps you monitor, log, and debug any issues that you face. Let's move forward in understanding what exactly LangChain is so that we'll be able to build GenAI applications more easily. Now, where do we need help right now? We need help in loading documents. We need help in configuring LLMs. We need help in vector storage, defining and storing vector databases, storing the vector embeddings into vector databases, and we need prompts also to be going through the embedding models. So for all these that are in and around a RAG application, we are using LangChain as the basic library. So I'm not sure if you have read about LangChain previously. If you have learnt it 1 year ago and now if you go through LangChain again, it has evolved dramatically. The LangChain has started as a simple framework for chaining prompts and models together, but in 2025 it has become a orchestration layer for the enterprise level AI applications. When I say enterprise level, it's being actively deployed across various businesses. Think of it as a conductor of an AI orchestra. It can handle multiple things as I showed you in the previous slide. The big breakthrough in this is LangChain expression language. So what it does is it lets us compose AI workflows by just declaring them, almost like, as I showed you during the previous module. It's just writing it in English, like vector store dot like that. And you should also go through about LangGraph, that is the recent addition in the LangChain ecosystem, where LangGraph is helping us build AI agents very fastly and help us solve complex problems. So uh, in an enterprise perspective, Langsmith provides the observability and monitoring after production systems are deployed. So what it does is it helps us trace every decision, measure performance, and debug issues in real time by helping us looking into what's happening within the LLM and how calls are being made. So, what are these core concepts that are available in LangChain that are enabling us to do all that we are doing? This architecture is fundamentally changed around runnables, which is nothing but composable and streamable way of coding. What does this mean in a practical perspective? Our chat models can now call tools dynamically. So, what is tool calling? Tool calling is similar to trying to execute something from your chatbot. If you understand me and following me correctly, if you remember, I wanted to perform an online search of availability of flight tickets on a particular date from one destination to another, where I would want a non-stop flight. So for this to be done, the chatbot has to go check in Google Flights, come back to you and return the output. So this is an external call that is happening. That's why this is a very huge thing that we can do very easily within GenAI applications and do some hybrid search across multiple data sources, not just what I said, you can do on multiple data sources. And the memory systems are particularly sophisticated now, and your chat history can be persisted and stored, and you can utilize that chat history to follow conversations. So this is a huge thing that has come out. Let's talk about let's talk about Hugging Face that we want to use for embeddings. Okay, before that, let's look at a modern example of LangChain. If you can see, let me bring up my laser pointer. So here we are trying to import chat prompt template from LangChain core dot prompts. So this is the library. And within that library, we have sub-library prompt, and this is the function chat prompt template. For us to chat with an OpenAI API, we are borrowing from LangChain underscore OpenAI chat open API. From LangChain core, once again, we are from output parser sublibrary, we are taking string output parser. Using these functions, we are now going to use LangChain expression language to declare and send a prompt into the LLM. So what is our prompt? We are basically telling the system to be a helpful assistant in specializing in domain that we input, and user input is directly taken into the LLM. We are declaring LLM here using the chat OpenAI module that we imported, and we are using the model GPT-4o with temperature 0. If you observe, when I say temperature very low, which means we are focusing only on that domain, and we are not letting LLM to create anything or imagine anything. Output parser, we have set it to string output parser because we want it in strings. Now, chain composition with pipe operator. If you see, we are declaring a chain saying prompt that is declared above should be sent into LLM, and the output LLM should come out as a string output parser. So it's like a chain if you observe. That's why it's called LangChain. As simple as that. So for each chunk in that chain that we are sending it as a stream, when I say domain is data science and I'm inputting explain transformer attention mechanisms, and we are trying to print the chunk and end, and we are flush equal to true as in print everything that is there. So this output will be giving us the output that is coming out from the LLM in the form of string format. So this is an example of LangChain. Now let's talk about Hugging Face. Hugging Face, as we discussed, it helps us in tokenizing the data. It gives us variety of data sets. It helps us accelerate our work by providing us transformers and making our computational work very easy, where we need computational embeddings to be done. So all these computational related aspects that are there within the RAG concept, Hugging Face makes it easy for us. So let's understand what it does. So it provides us transformers, latest model architectures and optimizations that are available in our current market. And we have now over 5 lakh models in the hub, Hugging Face hub. And that's not just transformer models. We are talking about multi-model models, specialized domain models, and even models that are optimized for specific hardware. So it also depends on the hardware, right? Now I wanted to use NVIDIA Triton, and I don't have that capability to buy the entire NVIDIA hardware. So for that specific hardware, if you want to utilize certain transformers, we can use them. So the inference endpoints service is particularly exciting because we can deploy any model with auto scaling, which means we don't have to worry about the cost. Auto scaling means, for example, today if I use only 1% of its capacity, will be built only for that 1%. Tomorrow, if I use 20% of its capacity, will be built for 20%. So this is called auto scaling. This way, we can reduce our bills on cloud offerings like AWS, Lambda, etc. Now, if you see what else this Hugging Face can offer. So okay, let me put it in a simple manner. There are multiple ways of fine tuning here. Those are offered simply as a model within the Hugging Face. So you can just import them and use them. So this is the flexibility that our Hugging Face is giving. Now let's compare the entire ecosystem that we have just discussed and see what are the tools that are emerging out, in this field, right? Each tool that you see has found its sweet spot in the AI development stack. LangChain excels at orchestrating complex AI workflows. So think of it as a multi-step reasoning, and you can also build agent systems, RAG pipelines that need to handle complicated business logic. Now your Streamlit dominates the UI layer. You don't have to go and learn UI separately. It's the fastest way for you to build an interactive interface for these AI applications that we want to build and deploy them. Hugging Face is our go-to model warehouse where we can find engines, whatever specialization we are targeting and whatever scale we wanted to deploy. And the emerging tools that you see on your extreme right are filling the specific gaps. For example, AutoGen is a multi-agent collaboration. So AutoGen can help us build agents. Langsmith for production observability. Arrays is another tool that helps us in observability that is fastly being adopted. So this is the entire ecosystem that will help us build applications in GenAI. Now, what are the future trends? As I told you, future is all about multi-agent systems that are coming out from Azure, AutoGen, Crew AI, collaborative AI workflows. And there are advanced observability aspects that are coming out of Langsmith. Edge deployment, as in if we wanted to deploy in our local machines. So we can use Olama, that was from Meta. For code generation, we can do GitHub Copilot integration within our IDEs. For example, my VS Code has Copilot integrated in it. There's also a tool called Cursor, similar to GitHub Copilot. It can also be utilized in the IDEs. Workflow orchestration, perfect for orchestrating big ML pipelines. So we can you also use GenAI apps to include in the workflow orchestrations. Mainly, AI safety tools and model risk management are trending nowadays to safeguard whatever we are building. So this brings us to the end of all the modules. I hope we are able to understand the basics and building blocks of GenAI applications, which includes RAG applications, agentic RAG applications, agents, multi-agents, and also we spoke about observability, which is for you to explore more and more there, which will help you in observing the productionized applications. Thank you so much. Hope you're following the demos. All the very best for the live sessions. Thank you.